All right, we're going to take a look at an example where we're going to explore marginal profit. So in example 1, we have the cost of producing and selling X units of a commodity per week is given by C of X equals 7,000 plus 2X, and the revenue of selling X units per week is given by R of X equals negative 0.001 X squared plus 10X. Part A, I just want to find the marginal profit function. Well, if I want the marginal profit function, that means the derivative of the profit function. And in this particular problem, I don't even have the profit function, so we have to start there. So all I have to work with is my cost function and my revenue function, but that's enough for me to find profit. Because profit, remember, that's how much money you get to take home at the end of the day after you pay your bills. So you're going to start with how much money you made in sales, which is your revenue, R of X, and then you're going to pay your bills. You're going to take away your cost function from that, so minus C of X. So to find my profit function, I'm looking at R of X minus C of X here. So let's go ahead and find our profit function. R of X, that's negative 0.001 X squared plus 10X minus my cost function, which in this problem is 7,000, plus 2x. Remember that your cost function does absolutely have to be in parentheses because I want to show that I am distributing this negative sign to both of these two terms. I want to subtract both of those two terms. So I like to change that minus to a plus and then change the signs on all of the terms of my cost function. So if I combine my like terms here, P of X, let's see, I still have negative 0.001 X squared. I have 10X plus negative 2X, that'll give me plus 8X, and then plus negative 7,000. We'll just write that as minus 7,000. So there is my profit function, but that's not what I was asked to find here. I wanted to find the marginal profit function. So marginal, remember, that's just going to be a fancy word for find the derivative of, in this case, your profit function. So I'm looking for P prime of X. Well, here I can just go ahead and use my power rule. P prime of X, that is going to be negative 0.002X plus 8. Derivative of negative 7,000 is, of course, 0. That's a constant. So here is my marginal profit function, P prime of X. So very cool. We've got this P prime of X, but I think what's even cooler is what we can do with it once we have it and kind of what sorts of information it tells us. So in part B, I want to find the marginal profit at a production level of 1,000 units per week. So remember, X, if I go back up, X is the number of units of a commodity per week. So here, this 1,000, that's my X value. So I'm just going to take that, plug it in for X into the equation for P prime that I just found in part A. So here I'm looking for P prime of 1,000. That's going to be negative 0.002 times 1,000 plus 8. Here I should end up with negative 2 plus 8. I should end up with a positive 6. So here is my marginal profit. It's $6, which by itself I don't think doesn't really mean anything. Most people would say, okay, I don't really know what marginal profit is telling me. And that's what I want to talk about in the next part is, okay, we've got this $6 as our marginal profit. What does that mean? So I'm going to interpret those results. So the first thing I like to do when I'm interpreting the results of these problems is talk about our production level, because the marginal profit is going to change based on your X value, based on what value you plug in for X. So we want to make sure that we mention that. So I'm going to start off by saying at a production level of 1,000 units per week, now I'm going to look at what is this $6 telling me. Well, that $6, if we look at how we found it, we found that by plugging 1,000 into P prime. Remember, P prime, that's the derivative of P of x, my total profit function. So the derivative is telling me the rate of change, in this case, of my total profit function. So this $6 is going to tell me how my profit function is changing. And don't overthink it here. It's relatively intuitive, I think, that we're going to look at that and say, well, if my profit is changing, profit is a number, that can either change one of two ways. It can either go up, it can increase, or it can go down, it can decrease. I suppose it could stay constant, but for this problem here, we're going to say that it's either increasing or decreasing. I'm going to look at that number that I found in Part B, which we said was a positive $6. To interpret and determine whether it's increasing or decreasing by that $6, I'm just going to look at the sign of that value. If it's positive, then it's increasing. If it's negative, then it's decreasing. So in this case, we ended up with a positive $6. What that means then is that our total profit is increasing by $6, but I want to also say how often is it increasing by that $6? Is it every week, every month, every year? For that, it's going to depend on what your X value was. Well, X was the number of units that I manufacture in a week. So I'm going to say that the total profit is increasing by $6 per unit that I manufacture. So if I'm currently producing 1,000 units and I chose to increase my production, right now I would expect my production, backwards. If I'm currently producing 1,000 units, and I choose to increase my production, I choose to make more units, I can expect my total profit to increase by about $6 for every additional unit that I make. Now, if I stray far away from that 1,000 units, if I start making, say, 2,000 units, then the change in my total profit is going to change. But as long as I'm staying relatively close to 1,000, I can expect my total profit to go up by about $6 per unit. So that's very cool. I want to look at one more quick example here. Part D, I want to find and interpret the marginal profit at a production level of 6,000 units per week. So just to recall, our marginal profit function, P prime of x, was negative 0.002x plus 8. So first of all, to find the marginal profit, I'm going to take 6,000, plug that in for x. So P prime of 6,000. Here we're going to have negative 0.002 times 6,000 plus 8. This should end up being negative 12 plus 8 would give me a negative 4. So this is my marginal profit. This time is a negative 4. So if I wanted to talk about what this means, again, the very first thing I'm going to do is mention my production level. So here I'm producing 6,000 units per week currently. So I'm going to say at a production level of 6,000 units per week, now I'm going to talk about the rate of change of my total profit. So we came up with P prime was negative 4. Remember, that's the rate of change of our total profit function. It's the derivative of our profit function. So we can say our total profit is, and I'm going to look at the sign of this number. Is it increasing or is it decreasing? Is it positive or is it negative? Well, in this case, we had a negative $4. So if it's negative, that tells me that my total profit is decreasing by that $4 per unit. So in this scenario, if I'm currently manufacturing 6,000 units per week and I decided, hey, I want to make more of this, whatever this thing that I'm selling is, then in this case, I can expect my total profit to go down. It will actually decrease by $4 per unit. So that actually seems like a bad move for my company. If I want to increase total profit, I actually don't want to increase my production, because this tells me that my total profit will decrease by about this amount. So we can use marginal profit to help us determine what makes sense for our business. If we want to increase our profit, we're looking for a positive marginal profit. That tells us, okay, yeah, if we increase production, then our total profit will also increase. But in cases like this, where we had a negative marginal profit, in that case, it tells us that our total profit will decrease if we choose to increase production. So it can help inform your business decisions by telling you what's going to happen to your total profit if you decide to increase or decrease your production.